This warm-up is not in your packet. We're going to pause the video here, write down all 4 equations, and solve them in the most efficient method. We'll give you about 5 to 6 minutes. Okay, so 1 doesn't factor. Nothing multiplies to 38 that adds to 14. So I'm going to complete the square. Move the 38 to the right. Half of 14 squared is 49. So now we can factor the left. Square root both sides. So that's plus or minus root 87. And move the 7 over. So we negative 7 plus or minus root 87. For number 2, it also doesn't factor. Nothing multiplies to 59 that adds to 6. So we'll complete the square again. Half of 6 squared is 9. Square root both sides. And move the 3 over. That's a 68 over there. Okay, for now number 3, anything multiply to 51 that adds to 14. Hopefully you figured out that it did factor, because 17 times 3 is 51. So if we do positive 17 and negative 3, that multiplies to 51 but adds to 14. So now we can set each factor to 0. So a is negative 17 and a is 3. Okay, and last but not least for number 4, it factors to x minus 11 and x minus 1. So x equals 11 and 1. Okay, so find page 67 and 69. You have 8 graphs graphed on those pages, and here on the board we have 8 equations. I want you to match these 8 equations to each graph. We're going to pause the video and give you about 4 or 5 minutes to do that. Some hints: I would start by looking at your x-intercepts. You know, these factors get you the x-intercepts. I would look if there's a reflection. You can look if there's a vertical stretch or a vertical shrink to try to match them. Okay, we'll pause the video here for you to do that. So now here's the answers. These 4 graphs are on page 67. I chose this first top left one because this positive 8 and negative 3 meant that there's x-intercepts at 3 and negative 8. So because the scale went by 2s, there's my x-intercepts at negative 8 and 3. So then for the next one on the right, the same thing, your x-intercepts are going to be 6 and negative 5. So here's the 6 and the negative 5. And now for the bottom 2 on that page, because of this negative 2, I knew it had to open down like this graph does. And then the x-intercepts match. Same thing, this graph opens down and has x-intercepts of negative 3 and 2. And then if you turn to the back, or to page 69, if we look at these 3 graphs, see how they all have the same x-intercepts? So let's think about which one's going to be not stretched versus vertically shrunk and vertically stretched. If you wanted to test a point, so let's pick another good point on the graph like this one here. That's at 4 6. And this one has a nice point at 4, 2. If you plug those in, you can see if it makes your equation true or not. Another way to think about it, because we have all three of these to compare, this one's the skinniest, so that was stretched. This one's the widest, so that was shrunk. And this one's in the middle, so that has no vertical shift, no vertical stretch or shrink. And then lastly, this one, those x-intercepts match and it opens up. Okay, so if I was here today, which I'm sorry I'm not, we would do stations around the room, but instead we're gonna do the work together on the board and in your packets. So find the station capture sheet in your packets. And the problem for number 1, they give you this equation, so go ahead and write it here on the blank. And we need to find the vertex. Now, the x minus 1 and the x plus 3 don't get me the x-intercepts yet because it's not in complete factored form. You have this plus 4 here. So let's multiply it all together. I'm going to distribute the 2. Combine my like terms. And there's our equation. I'm not going to complete the square because you have a coefficient that's not 1. So to find the vertex, I'm going to use the x-coordinate I know is going to be negative b over 2a. So that's negative 4 over 2 times 2. That's negative 1. So the x-coordinate's negative 1. Now, to get the y-coordinate, we have to plug it in. So you have two choices. You can either plug the negative 1 into the standard form, or you can plug negative 1 into what we started with and simplify. It's a personal preference. I'm going to plug it into standard form. So let's see, that is 2 minus 4 minus 4. That's 2 minus 8. That is negative 6. Except there's a mistake. Did you catch me earlier? Negative 6 plus 4, this should be a 2. Sorry about that. Oh, I can't even erase that 4 now. So this should be a 2, which makes this a 2. Which makes this a 2, and this a 2, which means this is wrong. So let's see, that's going to be negative 4. So this y-coordinate, excuse my mistake, so that's negative 1, negative 4. All right, let's see what number 2 does. Given this graph, write the equation and list any characteristics. Okay, so we have our x-intercepts. That's going to give us x minus negative 2 and x minus 6 as factors. But notice I don't know what the leading coefficient is, so I held the spot with an a. So let's find out what a is. We can pick any other nice point on this graph. And look, they're labeling this as 2, 8 for us. We could even use 0, 6. And let's find out the value of a. You can pick either point. I'm going to choose 0, 6 because it's a lot nicer to use. So 6 is the y. A I'm trying to find. 0 plus 2, 0 minus 6. So that's 2 times negative 6. That's negative 12a. So when we solve, we get negative 1/2. Does that make sense? The negative, our graph opens down. That's good. Okay, it's a nice sanity check. As far as characteristics, all right, let's put the vertex. Where's the vertex? What are the x-intercepts? And what's the reflection? So the vertex is at 2, 8. The x-intercepts are -2 and 6. And it's been reflected over the x-axis. Or you can say it opens down. All right, number 3. Factor completely over the set of complex numbers. Okay, let's see if it factors. 3 times 6 is 18. Does anything multiply to 18 that adds to -6? No. It's not going to factor that way. We could use that factoring pattern that we did yesterday in class with the a plus bi and the a minus bi, but I think there's a better way. If I factor out the 3, because I notice everything can divide by 3, we're left with x squared minus 2x plus 2. If I can solve that, I know that the solutions I get, or the roots that I get, are my factors, just like how we did station 2. So let's solve this. I'm going to complete the square. Oops, did that wrong again. It won't let me erase. Half of 2 is not 2. Half of 2 is 1. Squared is 1. So we're going to add 1 to both sides. And now we can square root. And add the 1 over, so we get 1 plus or minus I. So our factor, the 3 is the leading coefficient. We're going to have x minus 1 plus I, x minus 1 minus I. Oh, factored form down here. Well, I wrote it up there. One of my graphs. 4. Write the equation of the parabola that has the vertex of 5, 0 and passes through the point 7, -8. Okay. Well, they give us the vertex. So let's start with vertex form. That's a K. So we can fill in, oh, plus 0. That's really nice. Okay. So we've got y equals a, x minus 5 squared. Well, if it passes through the point 7, -8, this is an x and this is a y. We can plug them in to x and y and get a. So go ahead and do that. So I got -2. So y equals -2 x minus 5 squared. Let's see if that makes sense. If we graph 5, 0, 1, 2, 3, 4, 5, 0, and it goes through the point 7, -8 down here, well, the graph must open down, so it makes sense that our leading coefficient is negative. So if you look at number 5, we're given this equation, and it says, what is the axis of symmetry? Well, we haven't really talked about axis of symmetry, so let's stop. Let's not answer the question just yet. Let me draw you a quick graph. Let's say we're over here at -2, -3, and that's our vertex. So we have this parabola. The axis of symmetry is a vertical line that goes through the vertex because our graph is symmetrical on both sides. Because it's a parabola, this point and this point will be the same distance away from the vertex, and so on. So your axis of symmetry is the line x equals -b over 2a. It's the x coordinate of your vertex. So here's our given equation. Let's find negative b over 2a. That's 4 over 6. Reduce your fraction. That's 2/3. The axis of symmetry is a line, so you must write x equals 2/3 because it's a vertical line. Okay, and last but not least, station 6. Write the equation of the parabola that has a vertex at 0, 3, and zeros at plus or minus 3i. Well, if we know the zeros, we can write the factors. So that's y equals a x minus 3i, x plus 3i. And before we find that a value, let's multiply those complex conjugates, just the conjugates together. Let's get those factors down to a nice number. So let's see, that's going to be x squared, negative 3ix, and positive 3ix are going to be 0. So then this is negative 9i squared, which is negative 9 times negative 1, so plus 9. So now all that's left is to find that leading coefficient a. We're going to use our vertex to plug in to solve for it. So I get a is 1/3. So your equation, 1/3 x squared plus 9. Okay, your homework is in your packet. It is Making Practice Fun 51, page 75. The entire thing is your homework. Start it now. Make sure to check all your answers on Edline.